future AI wizards. Welcome back to the channel. I'm Wisdom Bird, and today we're diving into the fascinating world of artificial intelligence and machine learning fundamentals. And before you ask, yes, this is your complete guide to mastering the core concepts for the AWS Certified AI Practitioner exam. Now, if you've ever wondered how Netflix magically knows you're hooked on true crime documentaries, or how your phone unlocks with your face, even on a bad hair day, stick around. We're about to break down the AI magic behind it all. And trust me, by the end of this video, you'll understand these concepts so clearly, you could explain them to your grandma over Sunday dinner, and maybe even impress her. Let's get started. All right, let's start with the basics, and I mean the basics. Think of I like a Russian nesting doll, but instead of getting smaller, each layer gets more specialized and more impressive. Artificial intelligence is the head honcho, making machines do things that normally require human brainpower. We're talking speech recognition, problem solving, and decision making. That moment when your Amazon Alexa argues with you about the weather? Yep, that's AI. Some real-world examples include voice assistants like Siri, Google Assistant, and Alexa. Language translators that don't make you sound like a confused robot. Robotic arms in factories that never ask for coffee breaks. Speech to text that even understands your accent. Machine learning, ML, is where the magic starts getting personal. Instead of programming rules, we let the machine learn from data. It's like teaching a toddler to recognize dogs. Show them 1,000 dog photos. Eventually, they shout, "Dog," even at a blurry beagle in the distance. ML works in two key phases. Model training. Study time. Feed the model tons of labeled data, dogs, cats, confused cows. Inferencing. Test time. The model takes one look at a new image and says, "Ah yes, a golden retriever, having an existential crisis." Neural networks are inspired by the human brain. They're made of layers of neurons, nodes that pass signals, weigh inputs, and make decisions. Think of it as 1,000 mini-judges working together to figure out whether that image is a muffin or a chihuahua. Add multiple layers and you get deep learning, the tech behind self-driving cars, voice cloning, and even your YouTube recommendations. Take Tesla's autopilot, for example. It processes video feeds, sensor data, and makes split-second decisions like, is that a pedestrian or a very confident mailbox? Now we hit the crown jewel, generative AI. This is where AI doesn't just understand the world, it starts creating. ChatGPT writing your emails, DALL-E drawing a cat in a business suit, Amazon Bedrock fine-tuning AI for your company's data. This isn't just smart, this is next-level creative. So yeah, AI isn't coming, it's already here, and it's smarter, faster, and maybe just a bit sassier than you expected. Okay, time for some serious talk about the heavy hitters in the AI world. Foundation models and large language models. Don't worry, I'll keep it digestible. Foundation models are like the Swiss Army knives of AI. They're pre-trained on massive data sets, books, websites, documentation, and basically half the internet. Think OpenAI's GPT-4, Amazon Titan, Google's Bard, and Anthropic's Claude. These models come with generic superpowers, writing essays that don't sound like they were written by a caffeine-deprived robot, summarizing war and peace into a tweet, drafting emails so professional your boss might think you suddenly got promoted. You can even customize them with your own data. Want a chatbot that knows everything about your company's weirdly specific return policy? Fine-tune a foundation model with internal knowledge. But here's the price tag reality check. Training one of these giants costs millions of dollars and requires serious compute power. So unless you have a spare data center lying around, you'll be using pre-built models. Thankfully, AWS Bedrock gives you access to a whole bunch of them. Now let's talk about large language models, LLMs. LLMs are a subset of foundation models that specialize in processing and generating text. All LLMs are foundation models, but not all foundation models are LLMs. Think of it like squares and rectangles. LLMs are trained on huge text corpora, books, articles, websites, and yes, probably some spicy Reddit debates. These models handle language translation that doesn't make you sound like a confused time traveler, code generation that compiles on the first try sometimes, question answering without going off on philosophical tangents. Famous LLM examples? GPT-4, Google Bard, Meta's Llama, they're the LeBron James of text generation. And how do you use all this power? Through prompt engineering. A prompt is how you give instructions to these models. The better your prompt, the better your output. It's the difference between saying, write something, versus write a professional email declining a meeting because my cat has a dentist appointment. Clear, contextual, and specific wins every time. Time for a reality check. AI models are only as good as the data they eat. And trust me, these models have quite the appetite. Training data is the foundation of everything. But it's not just about quantity, it's about quality. You can't feed your model garbage and expect it to produce gold. As we say in the business, garbage in, garbage out. Here are the 3 pillars of great training data. 1. Diversity. Your data should reflect the real world, not just a narrow slice of it. If you're training a hiring AI only on resumes from one university, don't be surprised when bias sneaks in. 2. Quality. Accurate, clean data is key. One mislabeled cat as a dog, and your model could start making some very strange decisions. 3. Volume. More data usually helps performance, but only if the first 2 pillars are strong. Let's break down the main data types you need to know. Labeled data. This is the gold standard for supervised learning. Every piece of data comes with an answer. This is a dog. This is not a dog. Great for training, but time-consuming and expensive to produce. Unlabeled data. Raw, untagged information. Cheap and easy to collect, but you'll need unsupervised techniques to make sense of it. Structured data. Think spreadsheets. Rows, columns, and clearly defined fields. Employee records, sales numbers, stock prices. Classic structured format. Unstructured data. Text, images, videos, audio, basically anything that doesn't fit into a neat table. This is where the majority of real-world data lives. Now for the training data trinity. Training set, 60-80%. This is where the model learns patterns. It's the main course of the learning process. Validation set, 10-20%, used to fine-tune the model and prevent overfitting. Think of it as a practice test. Test set, 10-20%. The final challenge. This tells you how well the model performs on completely unseen data. It's just like learning to drive. You practice with an instructor, training, take mock tests, validation, and finally go for your license at the DMV, testing. Now, let's talk about feature engineering, basically giving your data a complete makeover so your machine learning models can actually understand it. A feature is just a fancy word for an individual piece of information about your data. If you're predicting house prices, features might be square footage, number of bedrooms, or whether the kitchen still screams 1975. Feature engineering is the art of transforming raw data into something your model can work with. Think of it as data styling, taking messy, real-world info and making it model-ready. Structured data techniques. Feature creation. Make new features from the ones you already have. Got house price and square footage? Create price per square foot, instant insight. Feature transformation. Convert data into more useful formats. Year built becomes house age. Much more intuitive. Feature selection. Like Marie Kondo for your dataset. Keep only the features that improve model performance. Ditch the rest. Scaling. Standardize features so they're on the same playing field. Don't let salary in dollars dominate just because the numbers are bigger than years of experience. Encoding. Convert text into numbers. Models understand math, not language. House type, detached, turns into numeric values. Unstructured data techniques. For text data, tokenization. Break down text into words or phrases so models can work with them. TF-IDF stands for Term Frequency Inverse Document Frequency. It highlights important words by downplaying common ones like the and. For image data, edge detection identifies the outlines of objects and images. Think of it as teaching your model where shapes begin and end. Color histograms. Measure the distribution of colors in an image. Great for image classification and analysis. Exploratory data analysis, EDA. Before you train your model, you need to understand your data. EDA is like going on a first date with your dataset. You explore, visualize, and get a feel for what you're dealing with. Look for patterns, spot outliers, and use visual tools like histograms, scatter plots, and bar charts. It's detective work, and it's essential. time for everyone's favorite ML topic, bias and variance. Don't worry, I'll make this painless, I promise. Think of model training like Goldilocks and the Three Bears. You want everything just right. The three bears of model fit. Overfitting. Your model memorizes the training data like a student cramming for a test. It does great on what it's seen, but bombs the real-world questions. It's too specific, capturing noise and outliers. Underfitting. Your model is too simple. It misses the patterns completely, like trying to describe a rocket launch using finger paintings. Not enough brain power. Balanced model. The Goldilocks zone. It captures real trends without getting lost in the weeds. This is the sweet spot we're aiming for. Bias versus variance. High bias. The model makes consistent errors in the same direction, like a basketball player who always misses left. High variance. The model's predictions are all over the place. Today it's a genius, tomorrow it's guessing randomly. Low bias, low variance. That's the dream. Accurate and consistent predictions. Models that both understand the training data and generalize well. Types of bias in AI. Selection bias. When your training data doesn't represent reality, like building a medical model using only college students and then wondering why it fails with seniors. Measurement bias. When your data collection is flawed or inconsistent, like comparing test scores from schools with totally different grading systems. Algorithmic bias. When the model learns and amplifies unfair patterns in the data. This is the one that grabs headlines, like facial recognition systems that struggle with certain demographics. Fighting the good fight. How do we reduce bias and improve fairness? Use diverse, representative datasets. Apply bias detection tools like Amazon SageMaker Clarify. Conduct regular audits and fairness evaluations. Use transparency, documentation, and, yes, common sense. Building responsible AI isn't just good practice. It's part of what the AWS Certified AI Practitioner exam is testing you on. We're in the home stretch. Let's cover some advanced concepts that'll really make you shine on the AWS exam. Self-supervised learning, the clever middle ground. Self-supervised learning is like being your own tutor. The model creates its own labels from the data. No human labeling needed. This is a game changer for areas like healthcare, where labeled data is scarce and costly. How it works. Pretext task. The model learns by predicting missing parts of data, like filling in missing words in a sentence or patches in an image. Downstream task. Then it's fine-tuned for specific jobs, like diagnosing medical images. Examples include BERT predicting missing words, image inpainting, and Facebook's Wave 2vec learning from raw audio. ML inferencing, putting models to work. Batch inferencing. Processes large datasets on a schedule. Think monthly churn predictions or weekly sales forecasts. Not real-time, but efficient and cost-effective. Real-time inferencing. Instant predictions. Fraud detection. Chatbots, recommendation engines. Great user experience, but requires solid infrastructure. Edge inferencing. Runs AI directly on local devices like smartphones or Tesla's onboard computer. Benefits include faster responses, better privacy, and lower bandwidth use. The Edge AI trade-off. Small language models SLMs, lightweight and fast, ideal for edge devices, like your phone's autocorrect or voice commands on smart speakers. Large language models, LLMs. Powerful but resource-heavy, suited for complex tasks and usually requiring cloud compute power. Master these concepts, and you'll be more than ready to tackle those tough exam questions. And there you have it, AI enthusiasts. We've journeyed from the basics of AI and ML all the way through to advanced concepts like self-supervised learning and edge computing. Remember, these aren't just exam topics. They're the building blocks of the AI revolution happening right now. Whether you're prepping for the AWS Certified AI Practitioner exam or just curious about how AI works, understanding these fundamentals puts you ahead of the curve. Hit that like button if this helped demystify AI for you, subscribe for more tech deep dives, and drop a comment telling me which AI concept blew your mind today. And hey, if you're studying for the AWS exam, good luck, you've got this. Next week, we're diving into AWS AI services and how they bring all these concepts to life in the cloud. Trust me, you won't want to miss it. Until next time, keep learning, keep growing, and remember, the future is AI, and you're part of it. This is Wisdom Bird, signing off.